Okay, I'm here in Composite Figures number 3 Google Jamboard. Number 1 says the school is building a new running track. The track is constructed from a rectangle and 2 semicircles. And so we need to determine the distance the runners run around the edge of the track. Runner answer to the nearest whole number. So you want the distance around something. So if it's a rectangle, you should think perimeter. If it's a circle, you should think circumference. Right? So I need to figure out, I know from here to here is 500, but how far is it from here to here around the circle? Well, if I think around the circle, I need the circumference of the circle. And the circumference of the circle is equal to pi times diameter. Do you know the diameter of the circle? You do, right? Right here, from here to here, from one side of the circle to the other side through the center, in this case is 102. So let's put C equals pi, which is 3.14, and then plug in the diameter of 102. Now, if I'm finding the area of this semicircle, let me call this semicircle A, then I would take my circumference and I would divide by 2, right? Because it's a semicircle, it's half of a circle. But over here, if I call this semicircle B, I have 2 semicircles. And so I would end up multiplying this circumference by 2 because I have 2 semicircles. And so if I were to multiply by 2, as you can see, these 2's right here would simplify. And so what you're left with is C equals 3.14 times 102. And when I put that in my calculator, I get 320.28. Okay? So if I start, let me get a different color here. If I start right here, this blue dot, and I'm going to go around the track. Well, from here to here is 500. Okay? Then if I go around this part and down this part, there's 500 more. Okay? And then if I consider the arcs of these circles, so these orange arcs right here, this would be the distance around the circle, right? If I were to put semicircle A and B together, it would form a whole circle, and the circumference of that circle would be this right here, 320.28. 320.28. Okay, so if I add all of these distances together, I get 1,320.28. Okay, and it told me to round to the nearest whole number, so this would be 1,320, and it would be square feet. Nope, not square feet, right? Because it's the distance around. So this is just like perimeter. This is singular units. So this is just 1,320 feet. Okay, number 2 right here, it's the same scenarios with the track, except it says now the inside of the track will all be grass. And so determine the area of grass needed to fill in the track. Round the answer to the nearest whole number. So now we don't want the distance around, we want the distance inside. So the space inside the track. So basically you're finding the area of this composite figure. Okay, find the area of this rectangle, call that shape A. Find the area of shape B, find the area of shape C, and then add all the areas together. Number 3, calculate the area of the shaded region. Okay, so I have 2 circles inside of what appears to be a square. Okay, now you have to figure out if it is. Let's figure out if it is or not. Well, let's say from here to here, we know that's 3. So from here to here is 3. From here to here is 3, and from here to here is 3. So it looks like if I go from the top of the shape to the bottom of the shape, I have gone 12. So yes, it does appear to be a 12 by 12. So it does appear to be a square. So if I find the area of that square, 12 times 12 is 144. Okay, that's the area of the square. So I need to find the area of this circle, and then take that away from the area of the square. Okay, again, it's like cutting out the circles. If I cut this circle out and cut this circle out, all I would be left with is the shaded region, which is what I want. Okay, so you need to find the area of this circle that has a radius of 3, and this circle that has a radius of 3, and then subtract that from 144. Number 4, given the circumference, find the area. Okay, we did this in composite figures number 2. So start off with the circumference formula. C equals pi times diameter. Okay, then plug in the circumference, 25.12. Plug 3.1 in for pi, and then solve for the diameter. Once you know the diameter, then you also know the radius. And so use what you know for the radius to find the area of the circle. Okay, I'll write down area of a circle equation, area equals pi r squared, and whatever r is, I'll put that in to this equation to find the area. Okay, I'll do the same thing in number 5. Go from circumference to area. Number 6, if the diameter is 90, what is the circumference? So circumference equals pi times diameter. I write that down and plug in what I know. I know 3.14 is pi. I know the diameter is 90. Okay, so the circumference is equal to 3.14 times 90. Remember, this is meters. Number 7, you know the radius, you want the area. So it's asking you about area, so I'm going to write down the area of a circle formula. Area equals pi r squared, and plug in what you know. I don't know the area, that's what I'm looking for. Plug in 3.14 for pi, and I plug in 9 for my radius. Okay, because the radius is 9. So square your radius, and then multiply by pi, and this will be square yards. Okay, number 8. Gives me the radius and asks for the circumference. So let's write down circumference formula, which is pi times diameter. Now it tells me to use the fraction form for pi, 22 over 7. So that's what I plug in. I'm looking for C. Now it tells me the radius is 14. But if I know the radius, I also know the diameter, right? If the radius is halfway across the circle, then the diameter is all the way across the circle. So I need to double that radius to get my diameter of 28. Now that I have it set up, I can cross simplify 28 over 7. That's 4. And so my circumference is equal to 22 times 4, which is 88. And my units are inches, right? So my circumference is 88 inches. Once you're done and have shown all your work, click View Assignment and turn in.